Hello everyone, welcome back to my channel. So in this video we are going to solve a problem on bisection method. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So the given question here is find a positive root of x cube minus x plus minus 1 is equal to 0 and correct it to 2 decimal places by using bisection method. Okay, so he has given f of x, so f of x is equal to x cube minus x minus 1. Okay, so this is equal to 0. So we have to consider two initial estimates because bisection method is an example of interpolation method. So we have to consider two initial estimates. Okay, so practically now we have to take the two initial estimates. So suppose since he has given to find the positive root, I am starting with 0 and I'll take x1 is equal to 1 again. So when x0 is equal to 0, what will be f of x0? So f of x0 is now what is the value? So 0 minus 1, so it will be minus 1. And what will be x1? F of x1 is equal to, so we'll get 1 minus 1 minus 1, which is equal to minus 1 again. So both values are same, so we cannot take both. So first of all we will consider some value x, suppose x2 is equal to 2, the next value. Okay, so what is f of x2? F of x2, I'm just okay, so I'm taking these two values in order to find the initial estimates. So if f of x2 is 2 cube minus 2 minus 1, just substitute in the place of x by 2. So it will be 8 minus 3, which is equal to 5, which is a positive value and this is a negative value. So the root is now between 1 and 2. So the initial estimates are x0 and x1, which are 1 and 2. So initial estimates is this 1 and 2. Okay, because f of x0 and f of x1 values are opposite to each other. Okay, so by the method of bisection, so first of all root lies between 1 and 2. This is what we have found. Okay, and f of 1 is negative and f of 2 is positive. This is another inference which we need. Okay, right. So by bisection method, the second approximation x2 is given by x0 plus x1 by 2. Okay, second approximation is given by x0 plus x1 by 2. So it is 1 plus 2 by 2, which is equal to 1.5. Okay, so what is f of 1.5? So f of 1.5, if you found, so it will be 1.5 whole cube minus 1.5 minus 1. So if you solve using calculator, you will get around 0.875, which is a positive value greater than 0. Okay, so when this value is positive, as I have told you, it replaces the positive root. Okay, in the initial estimate it replaces the positive root. So now root lies between, so negative will be same because this is not negative, so negative will be same, that is 1 will be same. Okay, and the new root will be 1.5, that is new estimate will be 1.5. If you observe, the difference between estimates here is 1 and the difference between estimates here is 0.5. This is how we are going to have. Okay, so for each approximation we are decreasing the difference between estimates so that we can reach the true value, or we can find the root of the expression, positive root of this given expression. Okay, now see, so now the roots lie between 1 and 1.5, right? So when this lies between this, next estimate will be x3. x3 will be 1 plus 1.5 divided by 2. 1 plus 1.5 divided by 2, which is 1.25. and f of 1.25 we have to find. F of 1.25 is 1.25 whole cube minus 1.25 minus 1. So if you solve for this, you will get minus 0.2968, minus 0.2968, that is, it is less than 0. Okay, so now it is replaced by a negative root. So what is negative root here? 1 is the negative root. So now root lies between, so 1 is replaced, because 1 is negative, so it is replaced by 1.25 and 1.5. If you observe here, the difference between the roots is 0.25 only. Here it is 0.5, but now it is 0.25. So we are further decreasing the difference between the two initial estimates. Okay, so next estimate is x4, which is equal to 1.25 plus 1.5 divided by 2. These two values bisected value. Okay, average value. What I mean is average value 1.25 plus 1.5 divided by 2, which is 1.375. And if you find f of 1.375, you will get its value is 0.224. Okay, 0.224 is again a positive value. Okay, so it is a positive value, so positive value here is 1.5. f of 1.5 is a positive value, we have got it as positive value, so it replaces the positive root. So the next roots are 1.25 and 1.375. Now the roots are bracketed between, root is bracketed between now 1.25 and 1.75. So next we have to find x5. Okay, so x5 we have to find. So x5 is 1.25 plus 1.375 divided by 2. Okay, so 1.25 plus 1.375 divided by 2, so we'll get around 1.3125. right? So and if you find f of 1.3125, you will get minus 0.0515. Okay, it is negative value, it is again 0, less than 0. So what is the negative root here? So negative root is f of 1.375 is positive, so negative root is 1.25. now it replace 1.25 is replaced by 1.3125, so the now root is bracketed between 1.3125 and 1.375. So next approximation x6 will be 1.3125 plus 1.375 divided by 2. Okay, so it will be around 1.34375. Okay, and if you find the value of f of 1.34375, so you will get a value which is equal to 0.0826, greater than 0. Yes or no? It is positive value. Now it is replaced by positive root, so f of 1.375 is positive. So this one f of 1.375 is replaced now with this. So now root is bracketed between 1.3125 and 1.34375. Okay, so root is now between these two values. So next approximation x7 is 1.3125 plus 1.34375 divided by 2. Okay, so you'll get around 1.3281, and f of 1.3281 is 0.01447, which is again positive. So if it is again positive, 1.34375 is replaced by 1.3281. So now the roots lie between 1.3125 and 1.3281. So 1.3281. So that x8, the next approximation is 1.3125 plus 1.3281 divided by 2. Okay, so it will get around 1.3203. Okay, so here it is, if you approximate, he has asked to approximate to 2 decimal places. If you approximate to 2 decimal places, it will be around 1.32. If you approximate here also, it is around 1.32. so we can stop here, because x7 is almost equal to x8, and the final value of the root is 1.32 by bracketing or by concatenating it to 2 decimal places. Okay, so the final answer will be 1.32. Okay, so this is how we can solve a problem, any problem, using bisection method. So first of all, you have to test for the values, because he has given to find the positive root, so you have to take the positive values. So I have taken 0, 1, 2, but I have found that x0 and x1, f of x0 and f of x1 are giving the same values, which are -1 and -1. So root cannot lie between 0 and 1. So we have gone to second option, that is x2 is equal to, I have taken it, become now positive. So root lies between 1 and 2. This is how we can find the initial estimates. This is the main task. So once you are finding the initial estimates by bisection method, it is the average value of the 2 initial estimates. So from that we have solved by taking or by decreasing the gap between the estimates, like this, as I have told you very clearly. So this is how we can decrease the gap between. So successive approximation, when you take one approximation to other approximation, we are decreasing the gap between the estimates. So here the gap will be decreased. For each approximation, the gap between the two estimates will be decreased, and finally iteration stops when you are having the two approximations approximately equal. Okay, so in this case x7 and x8 are approximately equal, so truncating to 2 decimal places, we'll get the value, or we'll get the answer as 1.32. Okay, so this is how we can solve by using bisection method.